Getting started with CloudBees high availability. Here's today's starting point. I have a CloudBees CI Operations Center 2.414.2.2. I also have two controllers set up on this Operations Center. Now, before we go take a look at how these controllers are set up, let's go take a look at the documentation for CloudBees high availability. If you haven't looked for it yet, we're going to start at docs.cloudbees.com. Under documentation, go to CloudBees CI, and then under install, we're going to scroll down and select high availability. Here you're going to see 4 pages that discuss high availability. Let's start first with the overall introduction. Now, as we can see here at the note at the top of the page, high availability is provided with CloudBees CI starting with version 2.414.2.2. Let's go ahead and take a look at a few of the capabilities that high availability brings us. First off, we get controller failover. Secondly, with CloudBees CI for modern cloud platforms, we get rolling restarts. We also get load balancing and auto scaling if you're also running on CloudBees CI for modern cloud platforms. Let's take a look at the overall architecture diagram of how this works. Now, this is true for CloudBees CI for modern cloud platforms and CloudBees CI for traditional platforms. Now, for this video, we're going to be focusing primarily on CloudBees for modern cloud platforms, but we will take a look at some of the notes for traditional platforms. Taking a look at this drawing, we basically have 3 different layers. We have our load balancer, we have our controller replicas, and then we have our shared storage. Now, if we scroll down below this image, we can see that the controller replicas make high availability possible. Number 2, the load balancer spreads the workload between the different controller replicas. Number 3, a shared file system is used to persist the content for the controllers. And finally, the way that this is being done is Hazelcast is being used within the controller replicas to keep the state in sync across all of the replicas. Now, you might be saying to yourself, well, didn't CloudBees have high availability in the past? And the answer is yes, but not active-active. In the past, it was active-passive, and also it only worked with CloudBees CI for traditional platforms. Let's go ahead and scroll down the rest of this overall introduction. We'll come back and look at horizontal auto scaling a little bit later. We'll go on down a little bit further. We'll talk about installing high availability. Now, if you're running on CloudBees CI for modern cloud platforms, everything you need is installed by default with 2.414.2.2. However, for CloudBees CI for traditional platforms, you're going to need to install a plugin. Now, let's go ahead and scroll down to the section called Considerations about High Availability. Number 1, nodes and agents. Now, this is really important, especially for the cases to where you are using a static agent or just a VM, a bare metal machine, whatever that is. Usually those machines are larger, so you might have multiple executors associated with the agent that you've set up. For high availability, an agent can only connect to a single replica at a time. Therefore, agents with multiple executors cannot be properly shared. So what does this mean? Each agent must only have one executor, one and only one executor. Let's think about a machine that has 32 cores. In the past, you may have set up a single agent that had 32 executors. Now what you're going to need to do is set up 32 agents, each with a single executor. Let's go down to running builds. Now, as high availability was being created, a lot of the normal use cases were being tested, but there are some exceptions that need to be taken a look at. Number 1, if you're using shared libraries, what you need to do now is you need to set them into a new mode called clone, and also configure Git to use a shallow clone. Secondly is non-pipeline projects. Problems can arise when you're running non-pipeline jobs like Freestyle, Matrix, or even Maven. When these jobs are run, other replicas can load the completed build metadata, but cannot take over the build successfully. So we'll see an example in a few moments about how a replica takes over a job. But if you're running Freestyle, Matrix, Maven, those jobs cannot be picked up. And as a result, if a replica terminates, any builds that are of these non-pipeline job types, Freestyle, Maven, Matrix, those jobs are going to be immediately aborted. And finally, if you're using the cross-team collaboration feature of CloudBees CI, it may not work across controllers. A couple of more items on this page: StageView and Blue Ocean plugins. Now, these 2 plugins may not accurately display running build information. However, CloudBees Pipeline Explorer does, because it has been built to take advantage of both high availability and non-high availability environments. And finally, hibernation. Now, if you think about it, if you're setting up a controller to be highly available, that is the complete opposite of hibernation. So maybe you've set up hibernation for your controllers to shut down during the downtimes, but at this point, if you've defined a controller to be highly available, you also cannot set it up to hibernate. Now let's go back up to our drawing real quick. about storage, and specifically shared storage. It's a file system. So if we were to take a look at the documentation for installation for modern cloud platforms, what we're going to see is a listing for Azure Kubernetes Services, Amazon Elastic Kubernetes Services, Google Kubernetes Engine, and just plain vanilla Kubernetes. Let's take a look at the pre-installation requirements for each of these. For AKS, what we're going to see is that for storage, if we're wanting to run a controller in high availability mode, we are going to have to be using the Azure Files NFS flavor. Notice here that you cannot use Azure Files CIFS flavor. You only can use Azure Files NFS. Let's go back and take a look at EKS. Now for EKS, sort of the same thing. We cannot use EBS for high availability, but we can use EFS for high availability. Let's go back over and take a look at GKE. For storage for GKE, again, we're going to need to use a different type of store. In this case, it's going to need to be file store in order to run a controller in high availability mode. Finally, let's go down to Kubernetes. For the storage type for Kubernetes, what does all of this boil down to? Well, all of these items, if you were to take a look at each of the sections, talk about you must have a storage class set up with read-write many access mode. That's the key part to this. Your storage class within Kubernetes has to be of a read-write many type. Another way to say it is if you cannot set up a storage class of read-write many, then you will not be able to take advantage of CloudBees high availability. Now, before we take a look at the example, let's go ahead and go back and take a look at traditional platforms. If you're still running traditional platforms, again, the storage, much like how you use storage for CloudBees HA for active passive mode, where you're using NFS, and specifically either NFS 3 or NFS 4.1. Same thing. But also, one more thing to take a look at is high availability active-active on a Windows environment is not supported. So you must be running CloudBees CI on a Linux-based system in order to take advantage of high availability. Now let's go ahead and take a look at the overview for high availability for CloudBees CI on modern cloud platforms. We're going to see this live in just a few moments, but what we'll see in the pod status column on the Operations Center, the number of replicas that are available to us. Now, when we create a controller that is used in high availability mode, as we set up that controller, we'll set a checkbox, and then we can set the number of replicas that we want. And then for horizontal auto-scaling, we can also set the maximum number of replicas along with a CPU threshold that will trigger that replica event. And then finally, we need to set a storage class name that is a read-write many type storage class. So let's go ahead and go take a look at the Operations Center I have set up. For the first controller, is just a standard controller. You can see this of pod status 1 of 1. But notice with MC2, I have 2 of 2 pods running. So just by taking a look at this, I know that MC1 is just a standard controller, not in HA mode, and MC2 is in HA mode because I see multiple pods running. Now, if we were to take a look at the configuration for MC1, what we're going to see is the PVC is bound using a storage class of standard, and it's also running as a stateful set 1 of 1 replicas. But let's go take a look at MC2. With MC2, what we have is our PVC is bound using a storage class of NFS client, but instead of a stateful set, we have a deployment. So we have 2 of 2 replicas. Let's go down into the terminal and take a look at this. So I'm going to say kubectl get pods. If we take a look at that, we can see that CJOC0, MC1, there's just one each of those, but with MC2, I actually have 2 items. If we were to run kubectl get stateful set, then we see that we have 2 stateful sets. We have one for the CJOC and one for MC1. If we do a kubectl get deployment, we can see that we have 1 deployment, MC2. And we can see that it's ready of 2 of 2, it's up to date of 2, and there's 2 available. So everything is just 2 across the board. If we were to go in and take a look at the configuration for MC2, we'll go to our configuration. We'll see that we have high availability checked. By default, when you check high availability, you get 2 managed replicas. You get 0 set for number of replicas. We'll come back and look at that in a few moments. And we also have a CPU threshold at 80. And then we've also set our storage class name to NFS client because that's my read-write many storage class that I have. So first off, let's go and see how this runs in high availability mode. We'll come back and take a look at horizontal scalability in a few moments. Let's go over to MC2. I have a job called make. If we were to take a look at the configuration for this job, what we see is a simple job setup. We're going to run make version. We're going to sleep for 30 seconds, and then we're going to run GCC version. So during this 30 seconds, I am going to cause a failure of the replica where this job is running. So let's go and see how that happens. I'll click on make and click on build now. If I take a look at the output of 2, what I can see here on the second line is this is managed by MC2, but more importantly, the last 4 FVJB. Now, if we go back over to our terminal, we can see that that is this pod that's running. So what I want to do is I want to go ahead and delete this pod while this job is currently running. Now let's make sure that we're down into our 30-second sleep, and we are. So I'm going to say kubectl delete pod and that pod. If we're to go back and look at our console, what we're going to see is that we're going to be resuming the build after the Jenkins restart. Now don't get scared about that, because what's really happening is we're just resuming the build on the other replica that's currently running. So JNM, if I take a look at this, that was this replica that was already running. So it was picked right back up. So the agent saw that it was disconnected from the controller that was running before, and then it reconnected over to one of the other replicas that was already defined for this controller. So we can see that it connected back up and it continued with the build and completed successfully. So at this point, if I was to run the job again, click on build now and take a look at the output of 3, we can see that the job was scheduled to run again on the JNM replica, because that's where it finished up the last run. Now, if we were to take a look at our pods, we can see that actually right now MC2 is just a different number at this point, because the other one was deleted earlier. So the deployment object in Kubernetes made sure that I had 2 replicas always running for this controller. So what you just saw here with HA works the same for both modern cloud platforms and for traditional platforms. But if you are running CloudBees CI for modern cloud platforms, you get one extra feature, and that's horizontal scalability. Let's go back over and take a look at the documentation for horizontal scalability. We'll go back over to the overview and go down to horizontal scalability. And what we have here is, once you are running controllers with multiple replicas, you can use horizontal pod autoscaling, or HPA. So what it's going to do is it's going to monitor the resource utilization and adjust the scale of the target to match the configuration settings. For example, if your utilization exceeds your defined threshold, the autoscaler increases the number of replicas. So what CloudBees recommends is you perform testing to make sure the appropriate thresholds you set don't affect your response times. So let's look at the upscale events. So currently right now we have 2 replicas defined. And let's assume for a moment that we're going to define a limit of 4 replicas. If a scaling event occurs, then any running jobs are not going to be rebalanced to the new replicas coming up. The builds are going to continue using the existing replicas. Any new builds will be dispatched randomly between replicas. Because we are using sticky session, any existing sessions remain on the same replica, and any new sessions are distributed randomly between the replicas. Now, not only do we get upscaling, but we also get downscaling. Once that process cools down enough to where the HPA can go ahead and start downsizing things for us, builds will be removed from replicas and will be adopted by the remaining replicas. And then any web sessions associated with a removed replica are redirected to any of the remaining replicas that are available. So let's go ahead and set this up within our MC2 controller. Before we do that, let's go back over to our terminal and let's type in kubectl get HPA. And right now we can see that we don't have any HPA resources currently in this cluster. Let's go ahead and go back over to our MC2 controller configuration. We'll go to MC2, configure. Let's change our maximum number of replicas. Now, what does this mean? If we take a look at this, it's the maximum number of replicas that can be run with autoscaling. You will have to set an upper limit for the autoscaling. If it's set to 0, that means autoscaling is disabled. So remember, the default when you turn on high availability for a controller is 2, 0, and 80. So I'm going to change this to 4. And I'm also, for this example, going to turn down my CPU threshold to 20. So instead of waiting till I hit 80%, I'm going to go ahead and cause autoscaling to occur once I cross 20% CPU threshold. Let's go ahead and click on Save. Now you'll notice that the current controller configuration is stale. Please restart the instance to apply the new configuration. Well, instead of just clicking on restart here, I'm actually going to do a full stop and let everything stop completely. I can confirm that the stop is done by taking a look at kubectl get pods. I can see that there's no MC2s around. Let's go ahead and click on start. As this controller is now starting up. It's going to start up with a minimum of 2 replicas. So if we were to take a look again at kubectl get deployments, we see our MC2. Now we see 0 of 2 ready. That's okay because things are still warming up. But now, if we run kubectl get HPA, now we can see that we have an HPA. A few moments ago we didn't, but now we do. We can see it's a deployment of MC2. Our targets are still warming up, but we know that we're going towards 20%. We have a minimum number of pods at 2 and a max number of pods at 4. I'm going to change this a little bit and I'm going to run HPA -- watch. And we'll wait for this to get completely up and running. So we should see the unknown change to not unknown. Okay, now that we have actual values, we see 14% out of 20%. Let's go back over to MC2. Let's go into our make job. And this time I'm going to click build now about 10, 15, 20 times, just enough to start building some back pressure on this controller. If we look on the left nav, you can see that we're up to 22 and we have a lot of builds scheduled for this one job. Now let's take a look at our HPA. You can already see here that we've crossed that 20% threshold. So once we get to the next entry for our HPA, we're at 52%, we can already see our number of replicas starting to grow. And finally, we're up to our max of 4 replicas. If we were to take a look now, our jobs are still running. Remember, this job had a sleep 30 in the middle of it, so it's okay for these to go ahead and queue for about 30 seconds. And then once they all complete, what we'll see is that we've got the percentage that's being used. Right now, you can see that it's already going down from 52 to 53 to 38, and now we're back down to 10. We can see all of our jobs completed successfully. And if we go back over and take a look at our operations center, and what we can see here is that we actually have 3 of the 4 replicas actually running under our deployment. So that's how you use horizontal scalability inside of CloudBees CI for modern cloud platforms. If you have any questions or comments, you can reach out to us on Twitter at CloudBees. If this video was helpful to you, give us a thumbs up. And if you haven't subscribed to CloudBees TV yet, why not? Take a moment, click on that subscribe button, and then ring that bell, and you'll be notified anytime there's new content available on CloudBees TV. Thanks for watching, and we will see you in the next video.